Well, hey guys, let's get your science notebooks if you don't have them so you can be sure to take notes as I go through the video this week. So when we were in class last time, we talked about the laws of motion, and we know that Isaac Newton was the first one to start to think about that and write those down so that we have those laws today. We know that the first law of motion says that an object at rest tends to stay at rest unless acted upon by an outside force, and that an object in motion tends to stay in motion unless that is acted upon by an outside force. The last thing I had you do in class before we left was to set up that ruler track and then roll a marble down the track. If you have that information, that data in your notebooks, go ahead and take it out and look at it right now. And in your mind, you can just talk right to me in the video. Tell me what you noticed about the starting spot and as it rolled down the ramp and then up the other side and its ending spot. Okay, I heard everybody tell me what you saw. Then we have a problem because the third law of motion says that for every action there is an equal and opposite reaction. We wrote those diagrams on the board about the marbles on the meter stick. And when we ran 2 marbles into 3 marbles, 2 always came out the other side. We saw that everything we did was equal, but it was opposite. We had an action, and then we had an equal and opposite reaction. But what I heard you just tell me was that if you started a marble at 4 centimeters on the left-hand side of your ruler ramp and it went down, it rolled up the other side, it did not go to 4 centimeters. So is Newton wrong? Because if Newton was right, it should go back up to 4. But instead, it went somewhere less than 4. So here's an example of what maybe your data looks like. Started at 4 centimeters on the left-hand side, and it only rolled up to 3 on the right-hand side. So again, was Newton wrong? Well, we find out that he wasn't wrong when we go back and we look again at that first law of motion where it said that an object stays at rest or an object stays in motion unless an outside force acts upon it. So in this case, we do have an outside force acting upon that marble, so it doesn't go up as far on the right-hand side as where we started it on the left-hand side. I'm going to direct you to a couple of web pages that I want you to read. The first one I want you to read about is what we refer to as forces. We've been talking about forces in class, but I want you to read about it, take some notes in your notebook so that you really begin to understand what forces are all about. Then the other thing I'm going to have you read about is friction, because friction is a type of force that limits the movement of an object. It says here a sliding object, but it could be a rolling object as well. So when we have the marble rolling down our track on one side and then going up the ramp on the other side, it doesn't go as far up the other side on the opposite side because of friction. So that will help us to begin to understand why our marble on the ramp didn't go all the way back up. So friction should help us answer the question of why Newton's law doesn't seem to work, but actually it really does. So I'll leave you with that today, and just make sure you take a look at those other web pages, put some notes in your notebook, and we'll pick up on this again next week. Thanks.